Okay, here we go with a basic example of using the distance formula. I wrote out the distance formula here in case you don't have it written down or you don't remember it. It's one you're going to need to memorize pretty soon anyways, but hopefully you get a lot of practice using it in the homework to help with that. So anyways, we're going to do this example where we find the length of the line segment joining these points. So I'll draw it out here to sort of illustrate how the distance formula works and why it works a little bit more. So we got 2, -1 is right here, and 4, 3 is here, and we can see that we're trying to find the length of the line segment means the same thing as the distance between those points that we're trying to find, and usually we call that d. So to use this formula, we have to see what is the x1. Let's say this is point number 1 here, this first one, and so this would be the x1 coordinate, and the x2 would be the coordinate over here, the x coordinate of point number 2, and this would be y1 here, -1, and then y2 would be 3. So to use the distance formula, we're going to get the square root of the sum of the squares. First, the x2 minus x1 would be 4 minus 2 plus the square of the y2 minus y1 would be 3 minus -1. And that gives you the square root of 2 squared plus 4 squared. And that is going to come out to be 4 plus 16 is 20. So we've got the square root of 20. And you could think of that as the square root of 4 times the square root of 5, which it is, and write it as 2√5 if you want. Or you could also plug that into your calculator. 2 times the square root of 5. Oh, whoops. That was weird. Try that again. It's about 4.47. Okay, so let's just go over real quick what that has to do with the Pythagorean theorem, because it's important to know the relationship between these two things. So we've got a right triangle here with a horizontal side that has length 2. That number 2 came out in the Pythagorean theorem as right there, that 4 minus 2. So generally you can always do your second coordinate here minus your first coordinate if you want to get the distance between them. That's 4 minus 2. Likewise, if you want to know this vertical distance, you can take the coordinate there and the coordinate there, and the distance between them is going to be 3 minus -1. So that generally works. You notice sometimes this will come out to be a negative number, like if I ordered the points differently, but like if this was point number 2 and the other point was point number 1, we would have ended up doing 2 minus 4 instead. If your x2 was equal to 2 and your x1 was equal to 4, that would give you -2. But then notice that when you square that, which is what you do here, you're still going to get the same thing, because a negative number squared is always positive. You'll still get +4. And so that's the same thing that you get when you do 4 minus 2 squared. That gives you +2 squared, which is also 4. So it doesn't really matter which way you subtract it, which one is point number 1 and which one is point number 2. Just wanted to write that down to check that you got it. Now let's go on to have you do an exercise. This one is the same idea as what I just did. Use the distance formula with these 2 points, and then plot the point so that you can see the right triangle that we're talking about. Kind of draw a picture sort of like what I drew right there. And And as usual, do it first. I'm going to do the answer in a minute, but you've got to try it on your own. If you get it wrong, that's okay. Just cross out your wrong answer and leave it on the paper, and then see mine. So, oops. Let's pause it here. Here's the answer I got. The distance is the square root of 208, which you can approximate with a calculator, is a little bit less than 14.5, about 14.4. Then to illustrate this here, I drew the 2 points. The distance is the length between them. This length here is what comes out to be about 14.4. The vertical distance here, that is negative 12 because you're going down. Your y coordinate is decreasing. And you can also see how that's the same as the distance between the numbers 3 and negative 9. So when you do negative 9 minus 3, you get that negative 12 result. And same thing here with the change in the x coordinates. That horizontal distance is the distance between the numbers negative 5 and 3 on a number line here, and that ends up being equal to 8. So that's where all those numbers come from, and that's what this has to do with the Pythagorean theorem. So I will see you in class. Have a good day.